Okay, the last subtopic for alternating current, it is 6.4, power and power factor. Okay, so the linear outcome for this subtopic, okay, it is applied in AC circuit consisting of RC, RL and RLC in series. Okay, the first linear outcome is the average power. Okay, power average, it is equal to I RMS times V RMS times cos V. Okay, average power, also known as a power loss that only occurs in resistor. Okay, the second thing is instantaneous power. Okay, the equation for instantaneous power, P is equal to IV, and the third one is power factor. Power factor denoted by cos V. Okay, it is equal to PR over PA. Okay, R here represent the real power. Okay, real power also equal to average power. Then PA is, A is for apparent. Okay, so this one is for apparent power, and apparent power is equal to I RMS times V RMS. Okay, look at to the first linear outcome, which is average power. Okay, in an AC circuit, the power is only dissipated by a resistance. Okay, none is dissipated by inductance or capacitance. Okay, so you have to remember that the average power is only dissipated by resistor, not by inductor or capacitor. Okay, so therefore, the real power is also known as the average power. Okay, that is used or gone is given by the average power. Okay, so the equation for average power, it is equal to I RMS squared R. Okay, because the average power is only dissipated by resistor. So average power also equal to real power. And average power also known as the power delivered to the resistor. Okay, power supplied by source to circuit, power loss or power dissipated. Okay, other than that, power average also equal to I RMS times VR RMS. Okay, careful here, VR RMS. VR RMS is equal to RMS voltage only across a resistor, not by capacitor or inductor. Careful, eh? Okay, so now look at to the power in a resistor, the instantaneous power, okay, in a resistor. Alright, so from the equation of the instantaneous power, power is equal to IV, okay. Other than that, power also equal to I squared R and also equal to V squared over R. Okay, so from here, P equal to IV. And since the equation for current is equal to I naught sine omega t, and the voltage for the resistor also equal to V naught sine omega t. So we have to multiply I and V, so we'll get I naught V naught sine squared omega t. Okay, so this is the graph for the power against time. Okay, for the power in a resistor. Okay, next the average power. Average power for the resistor, P average is equal to I RMS squared R, also equal to 1 over 2 I naught squared R. Okay, also equal to half V naught times I naught, and also equal to half P naught. P naught is the maximum power. Okay, a resistor in AC circuit dissipates energy in the form of heat. Okay, resistor dissipates energy in terms of heat. Okay, next, look at the power in a capacitor. Okay, the first one is the instantaneous power. Okay, from the equation of the instantaneous power, P is equal to IV. Okay, so equation for current is I naught sine omega t, and this V is the voltage across the capacitor. Okay, as in the pure capacitor section, okay, we get the voltage across the capacitor is equal to negative V naught cos omega t, right? So multiply I and V, we will get negative I naught V naught 1 over 2 sine 2 omega t, and I naught times V naught is also equal to P naught, which is the maximum power. So the instantaneous power in a capacitor will be equal to negative P naught 1 over 2 sine 2 omega t. Okay, this equation will give the graph of power against time for the capacitor, like this. Okay, next, okay, the average power. Average power in a capacitor is equal to 0. Okay, why? Because no energy is dissipated from a capacitor. Okay, and energy is just dissipates by the resistor. Okay, next, power in an inductor. Okay, so the instantaneous power in an inductor is given by the equation of power is equal to IV. So for the current equation is the same, equal to I naught sine omega t, but this one is for VL. VL is the voltage across an inductor, which is equal to V naught cos omega t. So by multiply current and voltage across an inductor, we will get P is equal to I naught V naught times half sine 2 omega t. Okay, so I naught times V naught also equal to P naught, which is the maximum power. So the equation for the instantaneous power in an inductor will be given by the equation of P equal to P naught times 1 over 2 sine 2 omega t. Okay, which is the graph for the power against time is given like this. Okay, next, the average power. Okay, average power in an inductor also is equal to 0. Okay, why? Because okay, it's the same as previous. Okay, no energy is dissipated from an inductor. Alright, the last part for this chapter, alternating current, is power factor. Okay, power factor is denoted by cos phi. Okay, so the equation for cos phi, okay, it is equal to power average over power apparent. Okay, it is the ratio. Okay, power factor is the ratio between the power average to the power apparent. Okay, the term cos phi is called a power factor, right? And since it is a ratio, so power factor does not have a unit. Okay, so the value of power factor can be vary from maximum of 1 to a minimum of 0. So the value of power factor is between 0 to 1. Right, next, a typical circuit has a power factor of less than 1. Okay, usually our circuit will have a power factor less than 1 because there is a power that is dissipated in the circuit. Alright, when phi is equal to 0 or cos phi equal to 1 or power factor is equal to 1, so it means the circuit is completely resistive. Okay, or when the circuit is in resonance. Okay, see, so it also means that when the value of cos phi is equal to 1, okay, it means that the circuit is in resonance. Okay, resonance is occur at this situation. Okay, so I think that's all for 6.4, and also it is the end of chapter alternating current. Thank you.